Next, we'll look at another feedstock pathway, which is seaweed. Now, please welcome Colin from Uluu.
Thanks. Thanks, and look, thanks for the opportunity to talk today. Very much appreciate it. I'll see if I can figure out how to work this. I'm from Uluu. Uluu is a small company based in Perth, Australia, and we are also making PHA. We heard a tremendous amount about PHA recently, the talk before last. So I won't dwell on introducing PHA as a material. It's enough to say that it's a material that we're looking at generally as a community to replace petrochemical plastics. So again, won't dwell on this too much, but plastic has actually been enormous benefit to society over the last 100 or so years. Everything from reducing waste, reducing food waste, allowing transport of food across borders, all the way through to reducing carbon emissions in different industries by, say, reducing the weight of the automotive industry and weight in cars and so forth. However, as again we've heard, plastics aren't without their problems. And in many cases, what we're looking at is overperformance of the material. The material is supposed to last and be persistent, but persisting for many thousands of years is what's causing the problems that we see currently with plastics. And so there are some metrics here. Also look at the production metrics along the bottom, where we can see the production of CO2, for example, and the cost of goods, which is very low for petrochemical plastics. At Uluu, we're looking at this problem, again, as I say, looking at moving towards PHAs, but using algae, macroalgae, as our resource. So instead of using fossil fuels or competing with food, what we're looking at is what we see as a bit of an untapped resource in terms of providing biomass for large-scale industrial biotechnology. When we look at our process, the first distinguishing feature is obviously the use of seaweed, but the second is that we're working largely in salt water. So this decreases our reliance on fresh water, also because seaweed and salt water tend to be co-located. It reduces transport costs and helps to improve the overall commercial performance of our process. So these numbers are based on predictions of how we will operate at scale. And what you'll see is that we're carbon negative, and I'll dig into that in a little bit, but we're also using far less fresh water than traditional PHA plays. We also use a water-only extraction process for PHA. We've moved away from solvents entirely, and in doing so, we both reduce costs because we don't have to pay for solvents, but we improve the overall performance of the process. In terms of being carbon negative, what you see here is how we perform in terms of carbon use or carbon footprint. And you can see that the use of seaweed drives us into a carbon negative position. Seaweed is about 3 times more productive than most of our land crops, so it grows very fast. Not every part of the seaweed is harvested. Some of it ends up being ending up in the environment, and that becomes fixed carbon. And so we end up in a position where we're pretty carbon negative. And then when we look through the rest of our processes, we can see that we're actually saving carbon compared with traditional methodologies of making our plastics, our PHAs. We aren't PHA formulators. We're not a plastics company. We don't make objects generally, but we do have formulation capability within the company. And this is important in that we're using that capability to demonstrate to people who do make plastics and plastic-based commodities that we can use our PHA as a drop-in alternative. And so these objects are made just by dropping in our product, our pellets, into ordinary plastics companies who will process them. So we have formulations for injection moulding, and the lids of these glass bottles are made with our product, Uluu. And we work closely with companies, and we have offtake agreements at the moment with Papanel, which is a pajama company, to make injection molded buttons for their pajamas. And that's going very well. We also have formulations for melt spinning our plastic, and so this is PHA-based melt spun material. Those are the pellets that we used. And we're able then to fabricate that, working again with partners who work in this space to fabricate the materials into just woven materials of any sort. Okay, I've rushed through that a little bit. I will say some of what I was going to say was said earlier. I'll introduce the team. We're a much smaller team than some that we've seen today. It includes both technical and commercial people. And you can see here our backers and also some of our industry partners. So I'll stop there, knowing that you're all ready for lunch. If you do have any questions of us, just come and find myself or Michael Pope, who's sat at the back at the moment, and come and have a chat with us.